Hello, this is Tom Brinkotter, the owner of Radio Site Test, a consulting company that does drone enhanced spectrum measurements. And this video is the third in a series on using the Aaronia isotropic antenna to make EMF, RF safety measurements. And I'm getting ready to fly this on my Matrice 600. I know in the earlier videos I said I was going to use my Whisper Ranger, but because I plan to use this Spectran V6 Plus, which takes more power, I decided to go ahead and use the bigger drone. It has a 14-pound payload, so quite a bit heavier lift than the Whisper Ranger. 3 IMUs to provide very stable flight. I've used it for 7 years now. It's just been a workhorse of a drone. So I just remounted the same kit you saw in the earlier videos, upside down on a clip on the bottom, powering it from a 19-volt drill battery. And there's the isotropic antenna. I'm going to change the measurements a little bit from what I had in the first two videos. I'm going to measure at 440 megahertz. And that then the FCC limits are different in that range. And units I'm going to use is going to be millivolts per square centimeter. That's the units the FCC uses in the above 300 megahertz range. Here's the GPS antenna. I don't have the batteries in yet, so I'll first just fly the drone without all the equipment, and then once I know that's all ready to go, I'll get everything hooked up and I'll show you what it looks like in here. So here's where I'm going to be monitoring the spectrum. So I'm using remote desktop to bring the measurements on the drone down to this notebook computer, and I have full control over the RTSA Suite Pro and the spectrum analyzer. Although I have a mission set up ready to go, I shouldn't have to do many adjustments. So I'm going to fly up to this 100 megahertz to 1 gigahertz log periodic antenna, and I'll transmit 50 watts from this antenna and park the drone in front of it and take a look at the level. Okay, the checkout flight went well. A little bit gusty, but drone handled it. Now I've powered up the Nuke computer, and remote desktop is running. So this actually is a view of the desktop, and I'll start the RTSA software and get that set up. So this may be a little hard to see, but I'll key up a portable radio and you see the marker pop up there. And so it's definitely receiving well. I have the isotropic antenna scanning all 3 axes, and so far this looks like we're good to go. Okay, the drone controller says everything's good. Let's arm the drone. All the displays on control looks good, so let's put it in the air. So I'm going to fly over to the tower and then key up that 50-watt transmitter. Okay, safely back on the ground. Didn't land in the center of the pad, but in the gusty wind I don't bother with that. And now I'm going to go pull the data off. So here's the raw Excel file that was recorded during the flight. Columns, latitude, longitude, power in dBm, and then power in watts per square meter. It's a simple conversion to go from that to milliwatts per square centimeter. I did a plot of the power versus time, essentially. And you can see the 2 times I keyed up, one the handheld portable, and then the much larger one, the 50 watts, when I was up in the air. It's fairly easy to take that spreadsheet data and take it to a website and make a Google Earth plot out of it. Here you see my flight path up to the antenna and back down, and if I click on the plot, you can see the values. Okay, so that's it for this third video. I think the Aaronia isotropic antenna did a good job of making the measurements. I do think it takes 2 people to do a good job at this, to both watch the data and watch the whole process. So it was very difficult to do this by myself, although I think everything is working fine, and I think the Aaronia antenna is perfectly capable of doing airborne EMF, RF exposure measurements. Thank you for watching.